Hi guys, welcome to my channel. Today we are going to be looking at the questions under elasticity. We have close to 20 to 30 questions here that we want to look at as far as elasticity is concerned. But before we commence the class, I would like you to hit the like button, and if you are yet to subscribe to this channel, don't forget to do that now, as this channel will really help you to pass any type of exams that you want to write, either Jamb, WAEC, NECO, SAT, and so on. And don't forget to share the video if you find it useful. Now, before we commence the class, I would like to call your attention to something on how to utilize this class judiciously. Don't just watch the video and see the solution, but for every question, make a pause. Answer the question yourself, try answer it. Do anything that comes to your mind that you think you are going to do if you're in the exam hall before you watch the solution. Then you can use that to evaluate your results. For example, the first question we have here states that an additional load to an elastic wire when the elastic limit is already reached will make the wire to A, break, B, be strained permanently, C, recoil, D, vibrate at a high amplitude. So pause the video now and answer the question. Then when you are done, you can keep watching. So that is how you are going to do for the whole of the question that we are going to be treating in today's episode. So I would like you guys to understand something. If you are yet to take a class on elasticity, you can check the description box. The video of the lecture on elasticity is there. So you can decide to watch the video before you come to answer questions here. And if you have watched the video before, then you can write down by looking at this one and answering questions and see what the solution likes. So without any further ado, let's get started. So the number one question that we have here, all these questions, mind you, they are all from Jamb past questions. So absolutely, we are good to go. An additional load to an elastic wire when the elastic limit is already reached will make the wire to A, break, B, strain permanently, C, recoil, D, vibrate at a high amplitude. Now, for us to be able to answer this question, I would like us to analyze it. So when I say break, on an elastic material, we have the following points there. We have the limiting, the elastic limit. We have the yield point. We have the maximum load, and we have the breaking point. Now, the material would always remain an elastic material, provided that the elastic limit is not exceeded. But if the elastic limit is exceeded, then it will either be around the yield point, or maximum load, or breaking point. And when the material gets to yield point, what happens to the material is that the material becomes strained permanently because it has stretched beyond its elastic limit. For that reason, the material becomes a plastic. Are you getting this now? So we don't have any further information here to say the material gets to the breaking point. Are you getting this now? Or the material gets to the point where it can no longer elast. Are you getting this now? What we can refer to as the maximum amplitude. Are you getting it? So since the only thing that we have here is that it exceeds its elastic limit, so that means it has gone beyond the elastic limit, and once it goes beyond the elastic limit, it's probably the yield point that makes it to become a permanent plastic. So for that reason, the correct option to this is going to be B. So do you understand that now? So is that what you choose? If yes, congratulations. So if no, I think you now understand what the right answer is now. So let's move to the next question now. So question number 2. The second question here states that if a load of 1 kilogram stretches a cord by 1.2 centimeter, what is the force constant of the cord if G is 10 meters per second square? Okay, I've told us several times, whenever you are given a question under calculation like this, the best way to answer such question is that you should interpret the question in line with the way it is being given. You get where I'm coming from now? So if that should be the case now, then we can do something. So what exactly are we doing? Let's get started and see. Have you answered the question? If you have answered it, let's go on. If not, pause it and answer the question. Then when you're done, you come to watch the solution. All right, so solution to this now. So we have that if a load of 1 kilogram, so the load is 1 kilogram, stretches a cord by 1.2 centimeter. So we have the extension to be 1.2 centimeter. So the extension is 1.2 centimeter. What is the force constant of the cord? So we are looking for K. Now, the question you should ask yourself is that what is the relationship between K and all these quantities given? So we have G also to be 10 meter per second square. Now, for us to get the relationship between K that we are looking for and the load and the extension and gravity, then we need to recall from Hooke's law that F is equal to KE. So we have that K is equal to F all over E. So how do we get F? Because we don't have F. F here. Now, force in this case is going to be mass multiplied by gravity. So divided by the extension E. Now, this is in centimeter. There's need for you to convert it to meter because the unit we have here is Newton per meter. So 1.2 centimeter, when you convert it to meter, so it means you are going to divide it by 100, and that should be giving us that E is equal to 1.2 times 10 to the power minus 2 meter. So slot this value into the given equation. So we have that the mass 1 multiplied by 10 divided by the extension 1.2 times 10 to the power minus 2. So with this, we can get the answer to this question to become K equal 10 multiplied by 100 divided by 1.2, and this will give us 833.3 Newton per meter, and that will be option B. So the correct answer to the question is option B. Is that what you choose? If yes, congrats. All right, so we'll move to the next question now, and that will be question number 3. So question 3 states that the point beyond which a stretched spring does not return to its original length is called the point beyond which a stretched spring does not return to its original length is called the A, breaking point, B, elastic limit, C, spring constant, D, elastic point, E, release point. Now, at this point in time, I believe you've paused the video and you already give your answer to the question. So let's see which is correct, your answer or my answer. So how do we get that? What we need to do is that we should analyze each of the options. Well, what's breaking point? Breaking point is the point in which further application of force causes the material to damage permanently. I get this now, that is, it deforms permanently. So can that be the answer? Absolutely no. Elastic limit. Elastic limit is the point beyond which an elastic material do not return back to its original position. So that's telling you that this answer is going to be what? Elastic limit. So what do you mean by this definition that the point beyond, if you watch the video on the elasticity, I've explained this in the class, the point beyond which a stretched spring does not return to its original length is called. So what do you mean by that is that by the time you, what is that point that if you go beyond it, what is that point that if you go beyond it, the material will not return back to its original position? So that is elastic limit, because anything that makes you to go beyond elastic limits, then the material cannot return back to its original position or size. and that is the right answer, B, elastic limit. Note, spring constant is the what? Is a unit force that can cause a unit extension. So it can be elastic point. We don't have something called elastic point, release point, so it has nothing to do with this particular question. So absolutely the correct answer to this is B. All right, so let's move to the next question here, and that's question 4. So we have that okay, sorry. All right, so the question states that a load of 5 Newton gives an extension of 0.56 centimeter in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? So how do we solve this question? I believe you are giving it a try now. So for me to solve this question, in order for you to understand it better, what I'm going to do right now is that I'll try to see if I can make it like a diagram. Okay, but is there any need for that? I'm not sure. Okay, let's go back to this. We have that a load of 5 Newton. So load of 5 Newton gives an extension of 0.56 centimeter. So the extension caused by this load is 0.56 centimeter in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? So we are looking for the extension caused by another load of 20 Newton. So absolutely, yeah. If you look at this now, you see that the units are already in what? Centimeter. So there's no point in you converting. So we recall that F is equal to KE, and we have that K is equal to F over E. So since we have that K is a spring constant, and we are still dealing with the same what? With the same spring. Are you getting this now? That is, we are still dealing with the same wire. It's not different wire. So the first constant will remain what? Constant. So for F1 and E1, so let me say this is E1 and this is what? F1, that's the load. This is E2 and this is what? F2. So if that should be the case now, we have that for K equal F1 over what? E1 is equal to K equal F2 over E2. So we can equate the two since the first the spring constant is the same for both of them. So what do we do? So we say F1 divided by F2, F1 divided by E1 is equal to F2 divided by E2. So if this is what I have, then I can replace F1. What's my F1? That's 5 Newton. I have 5 Newton divided by the extension is what? 0.56. 0.56 equal F2, that's 20 Newton divided by what? E2, and that is what we are looking for. So when you cross multiply, you have that E2 is equal to 20 multiplied by 0.56 divided by 5. So you have that E2 is equal to 4 multiplied by 0.56. And by the time you press your calculator, I believe that should give us 2.24. So 2.24 centimeter. So, and that's option C. So I want to believe that you understand this. So if you understand this now, let's move to the next question, and that will be question number 5. All right. So question 5. So question 5 states that the total length of a spring when a mass of 20 grams is hung from its end is 14 centimeter, while its total length is 16 centimeter when a mass of 30 grams is hung from the same end. Calculate the unstretched length of the spring assuming Hooke's law is obeyed. So how do we know the unstretched length of the spring? Absolutely, the unstretched length of the spring is referring to the original length of the spring. So they can ask it in different way like that. So we are referring to the original length of the spring. So let's say this is the length of the spring when there's no load on it. Let me make my line straight. So this is the original length. And then we have from the same point, okay, let me make it like this so that we are going to have a well explained diagram. So I have this, sorry. So this is the original length of the spring. And when a load of 20 grams is hung from it, we have what? 14 centimeter long. So absolutely, this will be longer than this. And this is 14 centimeter. And the mass that we apply to this one is 20 grams. Okay, so from the same ends, where the load is now what? Increased to 30 grams, we have this to increase in length. So this is 30 grams now. And the length of this is what? 16 centimeter. Now, how do we find the original length? Since we are told that Hooke's law is obeyed, then we have that K all over E, just like the previous example. So with this now, for the first one, F over E was going to equal to the second one, which is also what? F over E. So if that should be the case now, how do we solve? So we can solve by saying that the force, the change in force is going to be 20 minus 0, because this is when 0 force is hung on it, divided by the extension. So change in extension is going to be 14 minus the length. And this will equal to the change in force between this and this. That will be 30 minus 20 divided by, so that will be 16 minus 14. That's the change in length here. So do you get this now? So if this should be the case now, you can as well say that this is equal to 30 minus 0 divided by 16 minus L. So whichever one you choose to use there, you can get your answer. So I can decide to say 30 minus 20 divided by 16 minus 14 equal 30 minus 0 divided by 16 minus L. So anyone. So I would like to use this first two. So I will have 20 all over 14 minus L to equal 10 all over. So 16 minus 14. 16 minus 14 should give us something 2, right? Okay. So if I cross multiply, I will have that 40 is equal to 140 minus 10L. So if I collect the like terms, I'm going to have that 10L is equal to 140 minus 40. So I will have that 10L is equal to 100. So L equal 100 over 10. And that will give us that the original length L is equal to 10 centimeter. And that will be the right answer to the question. So if you have choose to use these two also, this particular two here, you will also arrive at the same result. I hope you understand this. Okay, so if that should be the case, let's move to the next question. So the next question here states that a force of 100 newtons stretches an elastic string to a total length of 20 centimeter. If an additional force of 100 newtons stretches the string 5 centimeter further, find the natural length of the string. So you should be able to do this by now, because this is almost exact like what we just finished doing now. So any which way, let me know your answer. Did you get it right? Tell me in the comment section right now if you get it right. So let's do the same thing. This is the starting point. This is when there's no force on it. And this is going to be when we have a force of 100 Newton on it. And the next one is going to be when we have additional force of 100 Newton. So that will be 100 plus 100, that's 200 Newton. So this one causes extension of 25 centimeter, and this one causes extension of 20 centimeter. And if you're a very smart guy like me, I already know that this is going to be 15. And how do I know? If I have this one to be 20, and when I add another 100 to it, it just increased by 5. it means initially the increment is also 5. So if I take away 5 from this, I will have 15. So is that part of the option? So that's the answer, option A. But if you don't want to do that, you can do what we did earlier by saying this is when it is 0. So you know that it is K equal F over E. So that will be change in force over change in the extension. So that will be 100 minus 0 divided by 20 minus 15. And that will equal to 200 minus 100 divided by 25 minus... okay, sorry, this is not minus 15 because we've not really gotten the answer. Sorry, my bad. So, okay. Yeah, so I'll just put this as L, which is the natural length. So let me put this like that. So this one is going to be minus 20. And this will give us 100 all over 20 minus L equal 100 all over 5. So if you have this now, so I can cross multiply, or I say divide both sides by 100 so that this 100 can cancel this 100. And then I have 5 equal 20 minus L. So L equal 20 minus 5. And that is 15 centimeter. Absolutely. So we are right with our prediction. So, and that is why you need to be very smart as a Jamb student. It's very, very important. It's not all questions that requires all your time to solve. Most of them, they just require common sense. Okay? Yeah, common sense is not common, but I know you have it. All right, so question 7 now. So the question 7 says the spiral spring of a spring balance is 25.0 centimeter long when 5 Newton weight hangs on it, and 30.0 centimeter long when the weight is 10 Newton. What is the length of the spring if the weight is 3 Newton, assuming Hooke's law is obeyed? Okay, if you guys see, you'll see that Jamb really like all these kind of questions, because for like 2 consecutive questions now, this is what we have, and this is going to be the 3rd one. So absolutely, so you can focus more on how to understand this, so that it can make your journey so easy. All right, so if I have this now, what will I do? Let's say this is 3 Newton force. And of course, this is 0 Newton force. This is 3 Newton force. I don't know what the length will be, but let me just call it L1. This is L0. This is L1. And when I had a load of, what was it called on it? 5 Newton to it. So it increased from 3 Newton to 5 Newton. So this is 5 Newton load. And that gives us extension of 25 centimeter. Right. And when I added 10 Newton to it, and that gives us 30 centimeter. So this is 10 Newton. All right. So if you look at what we have here right now, so how can we solve this? I think we should be able to solve this by saying 5 minus 3. You know, we can't just predict this. This might be kind of tedious for us to be able to determine. Reason being that, you know, this is 3 Newton, this is 5 Newton. Already we know that the extension between this and this is 5 Newton, right? So we know that 5 Newton force will cause extension of 5 units. So 3 Newton force is going to cause extension of what? Wow, guys, you can easily think of this. It means if 5 Newton force can cause extension of 5 units, that means 1 unit force is going to cause extension of 1 unit, right? So if that should be the case now, it means if I say 30 minus 25, that will give me 5. Absolutely, right? So that 5 now, if I take away 2 units from it, I should be having the what? The extension that will be provided by this. And that should just give me 23. Absolutely awesome. Yeah. You just need to think fast. That's Jamb for you. But let's solve it normally, the way it's supposed to be. So solving it normally, we have that 3 Newton, sorry. So let's just find the change between these two instead of starting from the very scratch here. So we have 5. Okay, let me write the first. K equal F over E. That's the formula we are using. So 5 minus 3 divided by 25 minus L1. And that will equal to 10 minus 5 divided by 30 minus 25. So what will this give us? This will give us 2 all over 25 minus L1, and that's equal 5 all over 30 minus 25. That will give us 5. So if I cross multiply, I have 10 equal 25 times 5. So that should give us 25 times 4, that's 150. So 25 times 4, that's 100. So this should give us 125, right? Yeah, that should be 125. 5 times 5 is 5. 5 times 2 is 10. So yeah, that should be 125. All right. So 5 times that, that's minus 5L1. Okay. Am I right? Okay, I think I did. All right. So if this one should come to the other side here, so I'm going to be having that, what's it called? So let's say if I take this one to this other side here, I'll have 5L1 equal 125 minus 10. Okay. So this will give me 5L1 equal, so we take away 10 from this, that will give us 115, right? So L1 is equal to 115 divided by 5. So 115 divided by 5 will give us okay, so 5 in 11, that is 2. So 5 in 15, that is 3. So our result is going to be 23 centimeter. Absolutely. All right. So that is how smart you should be as a Jambite, and you will be able to trash any of your question under 1 minute. So let's move to the next question. And what's the next question now? So the next question states, a string of length 4 meter is extended by 0.02 meter. When a load of 0.4 kilogram is suspended at its end, what would be the length of the string when the applied force is 15 Newton? Okay, so how do we solve about this? So a string of length 4 meter. So the length of the string is 4 meter. So L naught is 4 meter, which is the length of the string, is extended by 0.02. So the extension caused is 0.02 meter. When a load of, so let's call that load, on a load of 4 kilograms, so let's just call it force, and that is 0.4 kilogram, is suspended at its end. What will be the length of the string when the applied force is 15 Newton? So we are looking for the length of the string when the applied force, so new length now, let me call it L1, when the applied force is 15 Newton. So how do I solve this? So we just need to go back to the formula that K equal F over E. So this is the same formula that we're going to be using. And how do we use that? So we can use it by saying that convert this one to Newton by multiplying it by 10. So that will be 4 Newton here. So I haven't gotten that. So we have that 4 Newton force provide an extension of 0.02. And let's see what the extension this one is going to provide. So that will be 15 divided by E. Are you getting that now? So if you cross multiply, you have 4E equal 15 times 0.02. So 15 multiplied by 0.02. So that will give us 0.3. So we have that E is equal to 0.3 divided by 4. So 0.3 divided by 4, so that will give us 0.075. 0.075 in meter. Yeah. So this is the extension caused by the force of what is it called? The force of 15 Newton. But the question is, what is the what would be the length of the string? So the question is, what would be the length of the string? So how do you get the length of the string when the force of 15 Newton is applied? So you just say L naught minus the E1. So if that should be the case, L is equal to 4 plus 0.075. So 4 plus 0.775, 4 plus 0.075. So that should give us a 4.075. So 4.075 can be written as 4.08 meter. So that's option D. So do you get this now? And that is how you can easily solve questions under elasticity, and I want to believe that somebody is getting this right. All right, so let's move to the next question, and that is question number 9. A spring of length 25 centimeter is extended to 30 centimeter by a load of 150 Newton attached to one of its ends. What is the energy stored in the spring? So we want to know the energy stored in this spring. So if you interpret this question correctly, L1 is given to be 25 centimeter. Sorry, L1 is 25 centimeter, and we have our L2 to be 30 centimeter, just like we have it there, and our F is 150 Newton. So the energy stored in a string or an elastic material is given as 1 over 2 Fe. So if that should be the case now, I'm going to have that the energy E is equal to 1 over 2 F into bracket L2 minus L1. So that will give us the extension we are looking for, right? So if that should be the case, the energy is equal to 1 over 2 times 150, then multiply by L2 is what? 30. That's 30 minus 25. So if that should be the case now, E is equal to 2 here 1, 2 here should be 75. So you are having 75 multiplied by 5. Yeah. So that will give us wow. Okay. For us not to go, okay, so I have 5 here. So this will be 5 in centimeter. But remember, we're looking for energy. So there's need for us to convert this to meter. So 5 centimeter to meter is going to give us 0.05 meter. So we say the energy is equal to 75 multiplied by 0.05. So E, which is the energy stored in the string, is equal to 3.75 joules. So 3.75 joules is going to be our answer, and that's option C. All right, so we'll move to the next question right now. So the question states that a spring of force constant 300 Newton meter. So K is equal to 300 Newton per meter. Is compressed such that its length shortened by 3 centimeter. So the extension is 3 centimeter. And I want you guys to understand something here. Extension can either mean to increase or to reduce. Are you getting it now? So extension in the negative direction, that is when you compress something, the extension you have there is towards the negative direction. And when you extend something, the extension you have there is towards the positive direction. So this compressed is still what? The extension, 3 centimeter. Calculate the energy stored in the spring. So how do we know the energy stored in the spring? This is quite simple. So when you are given the force constant, you just know that the energy is equal to 1 over 2 Ke square. All of these have been proven in the video, so you must have watched that. And if you have not watched that, again, don't forget to check the description box for the link, and you watch the video and understand the topic more. So this is going to be E equal 1 over 2 multiplied by K, which is 300. But remember, this have to be in meter, not in centimeter. So that's 0.03 meter. If you don't know how to convert from one unit to another, also check the description box. You're going to find a video on unit conversion there, and it's going to do you a lot of favor on how to convert to any unit in physics. All right, so let's move on now. So this is going to be multiplied by 0.03 square. So the energy is given as 150 multiplied by, so 0.03 square is going to give us what will be the value that will provide for us. So that will give us something like 0.009. Okay, so what would the value now be? So E equals 150 times 0.009, and that will give us 0.135 joules. So you can press a calculator to check for that value. So this is the answer to that. So we'll move to the next question right away, and here we are. Okay, so the question here states that a spring of force constant 1500 Newton per meter. So K is equal to 1500 Newton per meter. All right, is acted upon by a constant force of 75 Newton. So the constant force F is 75 Newton. Calculate the potential energy stored in the string. So we are looking for the potential energy stored in the string. All right, guys, so I want you to understand that when I say potential energy is the same as kinetic energy. So but at this point in time, so looking for the kinetic energy stored in the string, we have 1 over 2, because you have the spring constant and the force. What's the relationship between the spring constant and the force while looking for energy? So that will be F squared all over K, 1 over 2 F squared over K. So we have that E is equal to 1 over 2 times, what's our F? 75. So we have 75 square divided by our K, which is 1500. So with this, we are going to be having 75 square to give us 5625 divided by 2 times 1500. That will give us 3000. So our potential energy that we are looking for is going to be 1.875 joules. So that's just the answer. And if you want to approximate, because right here in the question I don't have what's it called, oh, don't, I guess there's a mistake with the options there. So the potential energy is approximately the potential energy is approximately 1.9 joules. So I want to believe it's a typing error here. So this is supposed to be 1.9. So the correct option there is option A. I think that's a Jamb question, 1991 question number 7. So you can check 1991 question number 7. You can check your past question and see what the option A is. But I believe that should be the right option. So that's a typing error while factoring out those questions. Yeah. All right, so what's the next thing? The next question that we'll have here states that in an experiment to determine Young's modulus, for a wire, several loads are attached to the wire and the corresponding extensions measured. The tensile stress in each case depends on A, load and the extension, B, load and radius of the wire, C, radius of the wire and the extension, D, extension and the original length of the wire. All right, guys, so what do you think this answer is going to be? Okay, you forgot to like this video. Don't forget to do that. Kindly do that right away, because by commenting on this video, by liking this video, will allow YouTube algorithm to suggest this useful content for every other people that need such. So it's your like, it's your comment that really push the algorithm to know that this content is a useful one. So don't forget to do that now. Thank you, and let's ride on. So what's the answer to this question now? So in an experiment to determine Young modulus for a wire, several loads are attached to the wire and the corresponding extensions measured. The tensile stress in each case depends on. For you to be able to answer this question correctly, just ask yourself, what is the formula for tensile stress? So tensile stress is equal to force over area. So the option that will be the right option here is going to be the option that can result to force over area. Is that taken out? So when you say load and the extension, it can be, because force over area has nothing to do with what? The extension. So it has something to do with the load, but it has nothing to do with the extension, because right here, the load is the force. So we're looking for what depends on area, or what area depends on. So option B, loads and radius of the wire. Radius of the wire and extension. So anyone that has extension will not be the right answer, because the string does not have anything to do with extension. So it's only B that does not have what? Extension, and that should be the right answer. And why is that the right answer? Because the area of the wire is going to be measured in terms of R. because area of the wire is going to be assumed to be like a circle, and that will be pi r square. Is that ticking now? So absolutely, and absolutely, that's why the answer there is correct, because the area is absolutely depending on the radius. Okay, so let's move to the next question. So what the next question? The next question says that a piece of rubber 10 centimeter long stretches 6 millimeter when a load of 100 Newton is hung from it. What is the strain? All right, so how can we respond to this question? We are looking for the strain of this particular question here. So we have that a piece of wire 10 centimeter long, the original length of the wire is 10 centimeter, stretches 6 millimeter, so the extension of the wire is 6 millimeter, so extension is 6 millimeter, and then after a force of 100 Newton is hung on it, so this is the force of 100 Newton. So we are looking for the strain. Now if you look at the units that we have here, both the original length and the extension is supposed to have the same unit. So you have the choice to either convert this one to millimeter or you convert this one to centimeter. But I think dealing with a very small value is better than the big value. So let's convert this one to what? Centimeter, by dividing it by 10, and that will give us 0.6 centimeter. So we can now say we're looking for the strain now. So what is strain? Strain is given as extension over original length, and that will be what's our extension? 0.6 divided by the original length, which is 10, and that will give us 0.06, which is equivalent to 6.0 times 10 to the power minus 2. So it has no unit, because you know this one is in centimeter and this one is also in centimeter, so centimeter cancels centimeter. So the right answer to this question is going to be 6.0 times 10 to the power minus 2, and that's option C. All right, so we'll move to the next question, and yeah, so let's move to the next question. So question number 14. Awesome. So we have that a load of 20 Newton on a wire of cross-sectional area 8 times 10 to the power minus 7 meter square produces an extension of 10 to the power minus 6 meter. Calculate the Young modulus of the material. All right, so let's write down the things given in the question. So we have the force, which is the load, to be 20 Newton. We have the cross-sectional area of the wire to be 8 times 10 to the power minus 7 meter square, produces an extension of 10 meter, 10 raised to the power minus 4 meter. So E is equal to 10 raised to the power minus 4 meter. And we're asked to calculate for the Young modulus of the material if the original length of the wire, if the material of the wire is, if its length is 3 meters, so the original length is 3 meters. So do we need to convert anything here? Absolutely no, because everything is in their appropriate unit. So what's the formula for Young modulus? So Young's modulus can denote it with capital letter E. That is equal to stress all over strain. So what is the formula for stress? That's force over area, and strain is extension over original length. Far, near. So you have that the Young modulus is given as force times extension all over area times original length. So that will be the formula to use for this question. So we have 20 multiplied by what's our extension? That's 10 to the power minus 4 divided by what's our area? 8 times 10 to the power minus 7, then multiply by what's the original length? That's 3. All right, so with this now we can solve the question. So we can just say this is 20 divided by 24 multiplied by 10 to the power minus 4 plus 7. Yeah, so by applying the rules of indices there, I think that becomes something so easy. So the elasticity, so the Young modulus becomes 20 divided by 24. So if I divide, 4 can divide both, so I'll be having 5 over 6 multiplied by 10 to the power 3. So 5 over 6 should give us what? 5 divided by 6. Somebody should press calculator for me. Who is helping us? That will give us what, guys? Absolutely. That should give us what's it called? 5 divided by 6. 5 divided by 6. That should give us 0.833333. That part of the option? No, it's not. We made mistake somewhere. Area multiplied by the extension. Oh, there's a mistake here. So sorry. So you have to be careful also. Oh God. And the mistake is from here. Oh, I did not pick the right thing. I said far. That's the force multiplied by the original length over area multiplied by the extension. So that's what's supposed to be, not what it was. All right, so this is 20 multiplied by the original length, which is 3, divided by the area, which is 8 times 10 raised to the power minus 7, multiplied by the extension, which is 10 raised to the power minus 4. Absolutely. So this will be 60 over 8 multiplied by 10 to the power 11. So applying this is to these two, so we have this. So 60 divided by 8, that should give us 7.5. So we have 7.5 times 10 to the power 11 Newton per meter square. So that's the right answer to the question, and that is option B. So please, you have to be careful when you are doing this by far funny, so I made a mistake. That's a shortcut for me to deal with division of fractions. All right, so question number 15 now. All right, so what is the answer to this? A copper wire was subjected to a tensile stress. So the tensile stress, is 7.7 times 10 to the power 7 Newton per meter square. All right, calculate the tensile strain of the wire. We are looking for the tensile strain if what? The Young modulus. The Young modulus is 1.1 times 10 to the power 11 Newton per meter square. All right, guys. So what we do Young modulus equals stress all over strain, and that will give us 1.1 times 10 to the power 11. That's equal to, what's our stress? Our stress is 7.7 times 10 to 7 divided by our strain. We don't know. That's what we are looking for. So if you cross multiply, you have that strain is equal to 7.7 times 10 to the power 7 divided by 1.1. Sorry, too fast there. 1.1 times 10 to the power 11. So 7.7 divided by 1.1, then multiply by 10 to the power of 7 minus 11. Okay, so what would that give us, guys? 7.7 divided by 1.1 should give us 7. So this should give us 7 times 10 raised to the power minus 4. Okay, so do we have any answer like that there? Yeah, and that's option A. So do you get this now? And that's how we calculate for the strain. So what's the next question that we need to look into here? So that will be question 16, if I'm not mistaken. Okay, so the question states that if a load of mass 10 Newton, so that's the force, that's 10 Newton, stretches a cord by 1.2 centimeter, So the extension is 1.2 centimeter. What is the total work done? So we're looking for the total work done when a load of 10 Newton. So wow, how do we get that? So that should be very simple for us to do just by going back to the work done. Work done simply means what? Energy. So we have that the work done is equal to 1/2 Fe. So that's because we are having force and extension there. So we just have 1/2 times 10 times 1.2, and that will give us 6. That should give us 6 joules. Okay. What's the force? Oh, another mistake here. So I have to convert this one to meter. So that will be 1.2 times 10 to the power minus 2. So that's to tell you that it's just being so real. Yeah. All right. So I will have 2-year 1, 2-year 5. Okay, should I do it like that? No. Okay, let me just clean this. Okay, so this should be 1/2 multiplied by, what's our force? 10 multiplied by 1.2 times 10 raised to the power minus 2. So absolutely, this is what I'm going to be having here. So if I do the 2 multiplication, what will be my result right now? So this will be 10 times 1.2. That will give me what? 12. 12 divided by 2, that will give me 6. So I'll be having what? 6 times 10 raised to the power minus 2 joules. So that's the work done, and that will be option A. So do you understand this now? All right, guys. So let's move to the next one, which is question 17. So question 17 was there. So question says, if a wire 30 centimeter long is extended to 30.5 centimeter by a force of 300 Newton, find the strain energy of the wire. Right, so we're looking for the strain energy of the wire, and how can we find the strain energy of the wire? So this should be something very simple. So forget about the complex words used there, like the strain of the wire. Just go straight to looking for the energy. So you have okay, let me interpret the question before we move on. So you have the original length to be 30 centimeter, and you have the extension to be 30.5 centimeter, and the force applied is what? 300 Newton. So we're asked to find the strained energy. So the actual extension is going to be what? 30.5 minus 30, that will give us 0.5 centimeter. So that is the actual extension. You get that now? So if that should be the case, convert this one to meter. We therefore have 5 times 0 raised to power minus 3 meter. Okay, so that will be the right thing there. So the energy, we use 1/2. Since we have force and extension, we use 1/2 Fe, and that will equal to 1/2 multiplied by 300, then multiplied by 5 times 10 raised to power minus 3 meter. So what would that give us? And our result is just going to be 0.75 joules, and that's option B. Okay, so we can move to the next question right away. And what's that question? Okay, so we are looking for question 18. Okay, so here we have question 18. So the question states that the property of the material that allows it to be stretched into a wire is called A, brittleness, B, malleability, C, fragility, and D, ductility. I think this is the very last part of the lecture, if I'm not mistaken. So you can check and watch the video. I explain the meaning of every of these options there. So like the first one, brittleness. Brittleness is the ability of a material to break easily without warning. So like a glass now, so glass does not need to like tell you before it break. So it's not going to be the option. Yes. And the malleability is the ability of a material to be hammered or beaten and rolled into different shapes. So that can be the answer as well. And fragility. Okay, I think the word fragility is from the word fragile. So I can refer it to the same thing as brittleness. So the only correct answer there should be, what's it called? Ductility. So what's ductility? Is the ability of a material to break after passing through the elastic and yield point, that is ability to be stretched into a longer length. So that will be the right answer to the question. Is that taken out? So let's go to the next question, which is going to be question 19. All right. So question 19. So what do we have there? So let's see. Question 19. Oh, the force that produces angular deformation without a change in the volume of a material is referred to as. Okay, guys, who can answer this question for us here? So we have option A, tensile stress, option B, shear stress, option C, box stress, option D, comprehensive stress. All right, so when you say the very first option there, tensile stress, so either tensile stress or comprehensive stress, they are both the same thing. They causes change in length in the direction of the stress. So this and this, they are the same thing. I getting it now? They cause what? Changes in length in the direction of the stress. So what options do we have left? We have option B and option C. So what is shear stress? Shear stress causes angular deformation without change in volume, and box stress causes reduction in volume of a liquid. So the correct answer there is going to be shear stress. I think I also talked about this in the lecture, so you can do well to watch the lecture attentively, extensively. All right. So the last but not the least is that which of the following moduli, I think there's supposed to be double I there, which of the following moduli of elasticity is or are applicable to liquid? Young modulus, absolutely, it can be Young modulus, because Young modulus is the ratio of tensile or comprehensive stress to tensile or comprehensive compressive, I say comprehensive, compressive strain. So it can be, so because that one has to do with a solid, so get out. It's not going to be Young modulus. So Young modulus, any option that has Young modulus in it is not going to be the right option. So option C cannot be the right option. Okay, absolutely, C can be the right answer. So we'll rule that out. We have 3 to pick now. All right, so what's the next one? Modulus of rigidity. So we have modulus of rigidity. Do we have anything like that? No. So is there anyone that has the one that's supposed to be modulus of rigidity is supposed to be Young modulus, because it's talking about a solid material. So absolutely, any option that has human figure 2 in it will not be the right answer. So option D also is out. Option D is out. Option A is also out. So the correct answer is going to be option B. Even if I don't know the answer, it will be option B. Yeah. Because what? And it's even option B because I know the answer. And what is the answer? When I say bulk modulus is the ratio of hydrostatic stress called pressure to volumetric strain. That's taking? That's taking? Did you get that? I believe you should get that. All right, guys. So that's the answer to the question. Option B is the answer to the question. Thank you for watching the video. I try to be playful, but it's not just my person. Don't forget to share this video with your friends. Like the video, drop your comments and let me know the next topic you want me to solve questions on. That is all Jamb question on that topic. I'm going to put it down here. Thank you guys. See you in the next class.